right, we're going to go fly a kite. Isn't that fun? Woohoo! So the first thing I'm going to do is draw a picture. Okay. So when you're flying a kite, it's going to be kind of at a diagonal from you probably. Woohoo. All right. The kite is moving horizontally away from you with a speed of 7 meters per second at a constant altitude of 30 meters. Determine how fast the length of the string is increasing when the kite is 50 meters from the kite flyer. Well, what shape can I make out of this kite? A triangle, right. Especially since we're talking about altitude. All right, now, anytime I draw a triangle, I like to label the horizontal leg X, the vertical leg Y, and the hypotenuse Z. Just because X is your horizontal axis and Y is your vertical axis. I don't really care. You could do A, B, and C if you want to. I don't care. But I like to use X, Y, and then Z is kind of the logical third variable to use for the hypotenuse. Let's talk about what some of these variables are going to be. If the kite's moving horizontally away with a speed of 7 meters per second, so it's going that direction, speed is a rate of change. So 7 is the value of what variable? Dx dt. Good. Now, is it going to be a positive 7 or a negative 7? Why? Right, the length of X is increasing. Away is a little bit misleading because you might think negative in terms of away, but X is increasing, so dy dx or dx dt is positive. Because it's 7 meters per second, so it's in terms of time. And pretty much any related rate problem, any word problem that you do involving related rates is always with respect to time. I can't think of any one where it's not respect to time, but that's a good question. Okay, and when it's at a constant altitude of 30, so what variable is that giving you a value of? Y. Okay, y or dy dt? Y. Just y, good. Determine how fast the length of the string is increasing. So what variable is the length of the string, the rate of change of the length of the string? String, dz dt. When the kite is 50 meters from the kite flyer. So when z equals 50. No. Now what equation will relate x, y, and z together? Pythagorean theorem. Good. So x squared plus y squared equals z squared. All right, so the derivative will be 2x dx dt, good, plus 2y. Hold that thought. All right, now all I have to do is plug in the values of my variables and solve for what I'm trying to solve for, which I'm trying to solve for dz dt. All right, do I know the value of x? No. Okay, but can't I solve for it because I'm dealing with a triangle here and I know what y and z are. At some point in time, y is 30 and z is 50. So therefore, x would have to be 40. It's Pythagorean triple. Use the Pythagorean theorem if you need to. All right, so 2 times 40. Do I know what dx dt is? 7. Plus 2 times y is 30. What's dy dt? It's 0. Why? Right. Your altitude is at a constant height. It's not changing. So if your rate of change is nothing, then its derivative is 0. equals 2 times 50 times dz dt. Okay, now I'm not going to take the time to type this into the calculator, but I could probably tell you what it is, maybe. Ends up being 28 over 5 meters per second. Okay, now, someone said, do I even have to do dy dt in this problem? How could I have kind of left out the dy dt to begin with? Any thoughts? What? Okay, so you were just kind of thinking, dang it, I just changed the battery in this thing. Okay. We talked about the fact that y was not changing. It's okay to plug in a value of a variable that's not changing before you take the derivative. So if you had wanted to, we could have written our Pythagorean theorem as x squared plus 50 squared equals z squared. And when I take the derivative of 50 squared, what would I get? 0. Thank you. So if you know for a fact that a variable is not changing, you can go ahead and plug that value in before you take the derivative, and its derivative would be 0. But if you don't want to fool with trying to, if you kind of want to use that hard and fast rule of don't ever plug a value for a variable in before you take the derivative, then you would recognize that its derivative would be 0. Draw me a picture of the next kite and try and identify some variables. That just tells you its altitude at that instant. Like when I'm writing them, do I have to? Well, it would be the opposite. A positive rate of change is going to happen when your length is increasing. Not really, because it doesn't make any sense. Are any of my variables not changing in this problem? No, because it's being blown vertically and horizontally, and then it's asking for the speed at which the string is being paid out, so that's dz dt. So dz dt is obviously changing if it's asking for its derivative. All right, so once again, we're going to do x squared plus y squared equals z squared. Derivative 2x dx dt plus 2y dy dt equals 2z dz dt. This is kind of the same situation. So what's the value of x at this instant that we're trying to find the speed? 40, using the Pythagorean theorem. All right, so I know x, y, and z. I know dy dt, and I know dx dt. So I can plug in for dz dt, or find dz dt, right? Okay. To save time, I want to jump ahead and tell you that that value is 13 over 5. and it would be meters per second. Okay, part B, find the rate of change of the angle of elevation. It's not going to be the right angle. Is this the angle of elevation up here? No. Your angle of elevation is the line of sight to the kite and a horizontal. So theta right here. So I need to write some formula that involves theta. Okay? Sine of theta equals what? Good. Could I have done cosine of theta? And then I would have done x over z. Okay? Or I could have done tan of theta equals y over x. Doesn't matter. All right, so let's take the derivative. What's the derivative of sine theta? Good. D theta dt equals, do you want to do quotient rule, or would you rather change this to yz to the negative 1? Quotient? Okay. Derivative of the top is dy dt times the bottom minus the top times the derivative of the bottom over the bottom squared. Nope, z squared. And we're looking for the rate of change of the angle of elevation. So which one of these variables am I solving for? D theta dt. Okay, the trick to the whole reason I'm working this problem, I think y'all could have figured this one out pretty quickly, but the whole trick to this problem is figuring out what theta is, or the cosine of theta. This is still at all of these instances right here where x is 40, y is 30, and z is 50. So the cosine of theta at this instant is 40 over 50, or 4 over 5. Okay, go back to trig, where cosine is adjacent over hypotenuse, and the length of the adjacent side is 40, and the hypotenuse is 50. And then I'm looking for d theta dt. dy dt is negative 5. Z is 50. Y is 30. dz dt I found in the last problem, 13 over 5. So all I have to do is figure out what that right side is and then multiply by 5/4. What's your question tomorrow? Okay. It's negative 41 over 250, and your units are going to be radians per second. Negative 41 over 250. You can't read that? What is wrong with you? Yeah, anytime you're looking for the rate of change of an angle, it's always going to be radians per unit time. And no, it's d theta dt.